So a protocol that is defined, so basically for successful data communication to occur, the sender and the receiver must agree upon certain rules. Okay, and that's why a protocol is defined as a set of rules that governs the data communication. Doipayan, mute yourself. So protocol defines what is to be communicated, or how it is to be communicated, and when it is to be communicated. So there are three key elements of a protocol. One is the syntax, second is the semantics, and the third is the timing. Now, syntax means the structure or format of the data, and it is the arrangement of data in a particular order. So what is semantics? Now, it tells the meaning of each section of bits and indicates the interpretation of each section. And it also tells what action or decision is to be taken based on that interpretation. That is these are the semantics. Now, timing means it basically it tells the sender about the readiness of the receiver to receive such data, and it also tells the sender at what rate the data should be sent to the receiver to avoid the traffic of the receiver to receive the such data. Move on to the next slide, which is based on the standards. Now, these are basically what is standard. Standards are essential in creating and maintaining an open and competitive market for equipment manufacturers, and these are used to maintain such level. Okay, so that is used to ensure the interconnectivity and the interoperability between the various networking hardware as well as the software components. And data communication in this context, the standards are classified into two categories. One is the de facto standard, another is the de jure standard. Okay, now de facto standards that have not been approved by an organized body but have been adopted as standards through widespread use of this standard. Now, de facto standards are often established originally by manufacturers that seek to define the functionality of a new product or new technology. And de jure standard, so these standards have been legislated by an officially recognized body. Okay, and that's why some standard organizations are there, like International Organization for Standardization, which is called the ISO. It is a multinational body whose membership is drawn mainly from the standards creation committees of various governments throughout the world. Another is the International Telecommunications Union Telecommunication Standards. In short, it is called the ITU-T. Another is the American National Standards Institute, Institute of Electrical and Electronics Engineers, IEEE, Electronic Industries Associate. So all these are different standard creation committees, and there are lots of forums like these ATM forum, MPLS forum, Frame Relay forum, and also there is a regulatory agency which is called the Federal Communication Committee. So these standards are used in case of computer networking as well as in data communication technique. So this is the open system interconnection model, or it is called the OSI model. Now OSI, that is a reference model that describes how information from a software application in one computer moves through a physical medium to the software application in another computer. And as you have all you have seen here, there's that OSI layer was OSI model. This consists of 7 layers, and each layer performs a particular network function. Now, it was developed by the International Organization for Standardization, or ISO, in 80s, and it is now considered as an architectural model for the intercomputer communications purpose. So OSI model, it divides the whole task into 7 smaller and manageable tasks, and each layer is assigned a particular task, and each layer is also self contained, so that task assigned to each layer that can be performed independently. Okay, so this model actually, it is divided into 2 layer, upper layer and lower layer. Okay, the upper layer of the model mainly deals with the application related issues, and they are implemented only in the software, like this application layer. This is closest to the end user. Both the end user and the application layer interact with the software applications. And lower layer of this OSI model, this basically deals with the data transport issues, like this data link layer, physical layer. These are implemented in hardware and as well as also software, and the physical layer is the lowest layer of this model, OSI model, and is closest to the physical medium. And this physical layer, basically, it is mainly responsible for placing the information on the physical medium. Okay, so I will discuss one by one each layer. So these are the applications indicated in this figure for each layer separately. Now, these are the layer, and according to this layer, different protocols are used. Like for physical layer, the physical layer host router protocol is used, and the name of unit which is exchanged between the systems, that is the bit. And in case of data link layer, the data link protocol is used, where the frames are exchanged, then the packet is exchanged. Then in this way, so different protocols are used for different layer, and the unit, those are exchanged and differently specified into this table. Now coming to the first layer, which is called the physical layer of OSI model. So physical, the main functionality of this physical layer is to transmit the individual bits from one node to the another node, and it is the lowest layer. So basically, it establishes, maintains, as well as it deactivates the physical connections, and it specifies the mechanical, electrical, network interface specifications among these nodes, how they are connected physically. So basically, the functions of this physical layer is line configuration, data transmission, topology, and the signals. Now, in case of line configuration, it defines the way how 2 or more devices that can be connected physically. That is called the line configuration. And in data transmission, so it defines the transmission mode, whether it is simplex mode or hub duplex mode or full duplex mode between the 2 devices on the network. Last day I have discussed about the different modes of transmission: simplex, hub duplex, and full duplex. So these are defined using this function, data transmission function, means this one. So topology, all of you heard about this topology, means the way, how the network devices are arranged in which topology, whether it is the ring topology or star topology or bus topology. So different topologies are there. So it defines that topology which is to be used, as well as the signals. The type of signals can be what will be the type of that signal for transmitting and for information purpose, that is to be defined in this layer. So these are the different functions of physical layer. Next is the data link layer, the next layer. So basically this data link layer is responsible for the error-free transfer of data frames. Okay, now it defines the format of the data in the network, and also it provides a reliable and efficient communication between two or more devices or more nodes. So basically it is mainly responsible for the unique identification of each device that resides on that local network. And that's why these are connected via two sub layers. One is called the logical link control layer, another is called the media access control layer. I will not discuss about these sub layers. Okay, just remind it to how they are connected or what is the functions. I need to explain it here. Now the framing, different functions are there. Framing, the first is the framing. Framing means the here it translates the physical raw bit stream into packets, and this packet is known as frame. Now the data link layer adds the header and trailer to this frame. The header which is added to the frame contains the hardware destination and source address. Okay, and trailer, that is used to specify some error, overcome some error bit, or if any error is there, so it will be detected by that trailer. Another function is for physical addressing. Now it adds a header to the frame that contains a destination address, and the frame is transmitted to the destination address mentioned into this header. Flow control, that is the main functionality of this data link layer. And here what happened in this technique, through which the constant data rate is it is maintained on both the sides, so that no data get corrupted. It basically ensures that the transmitting section such as server with higher processing speed does not exceed the receiving station, which is lower processing speed. Okay, so it maintains the flow, the control. Error control, that is achieved by adding a calculated value in some technique like cycle redundancy check is there. So error minimizing technique, that is placed to the data link layer trailer, which is added to the message frame before it is sent to the physical layer. Now if any error seems to occur, then the receiver sends the acknowledgement for the retransmission of the corrupted frames. Lastly, the access control. So when two or more devices are connected to the same communication channel, then the data link layer protocols are used to determine which device has control over the link at a given time. So that is the function access control. Next layer is called the network layer. Now it is a layer 3 that manages device addressing, tracks the location of the device on the network. Now it also determines the best path to move data from source to the destination based on the network conditions, as well as the priority of the service, and some other factors are also included. So it is responsible for routing and forwarding the packets. Okay, The protocol used to route the network traffic are known as the network layer protocols. So different functions are available like inter-networking. So it is the main responsibility of the network layer, and it provides a logical connection between the different devices or between the different nodes. Next function is addressing. Now it adds the source and the destination address to the header of the frame. Now, addressing is used to identify the device on the internet. Next is the routing. So routing is the major component of the network layer, and it determines the best optimal path out of the multiple paths from the source to destination point. Last is the packetizing. So here network layer receives the packets from the upper layer. So and it converts them into packets. So this is called the packets, and this process is called the packetizing, and it is achieved by the internet protocol. Okay, there is a protocol called internet protocol or IP. So this protocol is used to achieve this function. Move on to the next slide, which is the transport layer. So it is the layer 4, which ensures that messages are transmitted in the order in which they are sent, and there is no duplication of data. The main responsibility of this layer is to transfer the data completely. It receives the data from the upper layer and converts them into smaller units known as segments. Okay, now this layer that can be termed as an end-to-end layer, as it provides a point-to-point connection between the source and the destination to deliver the data reliably. Now two types of protocols are used to perform the different functions. One is the transmission control protocol, or TCP. In short, it is called TCP. Okay, TCP protocol. And another is user datagram protocol. User datagram protocol. So the different functions are available, like service point addressing. What is that? That is, suppose computers run several programs simultaneously. Okay, and due to this reason, the transmission of data from source to the destination, not only from one computer to another computer, but also from one process to another process. Now this layer, this transport layer, adds the header that contains the address, which is known as the service point address or port address. And the responsibility of this network layer is to transmit the data from one computer to another computer, and the responsibility of the transport layer is to transmit the message to the correct process. Next is the segmentation and reassembly. So when the transport layer receives the message from the upper layer means from this station layer. Okay, because next to it, this transport layer, next to it, it has the session layer. So this is the upper layer. So when it receives the message from this upper layer, it divides the message into multiple segments, and each segment is assigned with a sequence number that uniquely identifies each segment. So when the message has arrived at the destination, then the transport layer reassembles the message based on their sequence numbers. So this is called the reassembly, segmentation and reassembly. Next is the connection control. So it provides two services, connection oriented service and the connection less service. So connection less service treats each segment as an individual packet, and they all travel in different routes to reach the destination. Now, a connection-oriented service makes a connection with the transport layer at the destination machine before delivering the packets. So in here, all the packets travel in the single route. Next is the flow control. So the transport layer that is also responsible for flow control, but it is performed end-to-end rather than across a single link. Okay. And last is the error control, where it is the error control is also performed end-to-end rather than across the single link, and the sender transport layer ensures that message reach at the destination without any error. Okay. Now, coming to the next layer, which is the session layer, that is the upper layer from the transport, and it is used to establish, maintain and synchronizes the interaction between the communicating devices. And different two functions are available, like dialog control and the synchronization. So in dialog control function, what happened, this dialog controller is used, and it creates a dialogue between two processes, or we can say that it allows the communication between two processes, which can be either half duplex or full duplex. Synchronization means this layer at some checkpoints when transmitting the data in a sequence. Now, if some error occurs in the middle of this transmission of data, then the transmission will take place again from the checkpoint. And this process is known as the synchronization and the recovery of that data. Next is the presentation layer. So it is mainly concerned with the syntax and semantics of the information exchange between the two systems. And it acts as a translator for a network. It is a part of operating system that converts the data from one presentation format to another format. And this is also known as the syntax layer. Now, different functions are available, like translation, encryption, and compression. So in translation, what happened, the processes in two systems exchange the information in the form of character strings, numbers, etc. So different computers use different encoding methods. Okay, the presentation layer handles this interoperability between the different encoding methods, and it converts the data from sender dependent format into a common format, and changes the common format into receiver dependent format on the at the receiving end site. Encryption here, it is needed to maintain the privacy of the data. So encryption is a process of converting the sender transmitted information into another form and sends the resulting message over the network. Compression means a process of compressing the data, that is, it reduces the number of bits that is to be transmitted. Now, data compression is very important in like multimedia, such as text, audio, video, that can be compressed according to our requirement. Next is the application layer, where this serves as a window for users and application processes to access the network service. It also handles issues such as network transparency, resource allocation, etc. And it provides the network services to the end user. Different functions are available, like file transfer, access, and management. So it allows a user to access the files in a remote computer, to retrieve the files from a computer, and to manage the files in a remote computer. Mail services are also available, like um, facility for email forwarding and storage purpose. It is happened here. Directory services, like for it is used in the distributed database sources, and it is used to provide that global information about various objects. Okay, so these are the different OSI model layers, different layers. Now coming to the next slide, which is basically the transmission media. So transmission media is a communication channel that carries the information from the sender side to the receiver side. And here the data is transmitted through the electromagnetic signals. Now the main functionality of this transmission media is to carry the information in the form of bits through the LAN. LAN means, I have told you earlier, that local area network. So it is a physical path between transmitter and receiver in data communication. Now, in copper-based network, the bits in the form of electrical signals, and in fiber-based networks, the bits are in the form of light pulses. All of you have already learned the optoelectronics last year, so you have some idea about the fiber optics. Now, in OSI model, the transmission media supports the layer 1, and therefore it is considered to be as layer 1 component. Okay, and that is the physical layer. So the electrical signals that can be sent through the copper wire, or can be sent through the fiber optics, or through wireless kinds of, like atmosphere or vacuum. So the characteristics and quality of data transmission that are determined by the characteristics of the medium as well as the signal. Now, transmission media is of two types: guided media or unguided media. Well, guided media means wired connection, and unguided media means wireless connection. Now, in guided media, medium characteristics are more important, whereas in unguided media, signal characteristics are more important. Okay, so different transmission media have different properties, such as bandwidth, such as delay, the cost and ease of installation and the maintenance, etc. So there are some factors are there, like bandwidth factor is there, transmission impairment is there, or they may have some interference. So it is to be considered when you need to design the transmission media. Okay, as per this chart, this here it is given that transmission media is divided into two parts: guided media and unguided media. Guided media is again divided into three types: coaxial, fiber optics, and twisted pair cable. Unguided media is radio waves, microwaves, and infrared. So I will discuss one by one this transmission media. The first is the guided media. So it is defined as the physical medium through which the signals are transmitted, and it is also known as the bounded media. Okay, now under this guided media, there are three types of media. One is the twisted pair cable, and another is the coaxial cable, and this is the fiber optic cable. Now, twisted pair is again divided into two categories. One is the unshielded twisted pair, or UTP. Another is the shielded twisted pair, or it is called the STP. So twisted pair is a physical media made up of a pair of cables twisted with each other. Okay, and this cable is cheap as compared to other transmission media. Now, installation of this twisted pair cable is very easy, and it is very lightweight cable. Now, a twisted pair consists of two insulated copper wires arranged in a regular spiral pattern. Okay, and the degree of reduction in noise interference is determined by the number of turns per foot, and increasing the number of turns per foot decreases the noise interference. So this is the figure of unshielded twisted pair, or UTP. Now it consists of two copper wires where each wire is separately encapsulated in PVC, polyvinyl chloride insulation. Bandwidth can be improved by controlling the number of twists uh, per foot, and also the manner in which multiple pairs are twisted around each other. And the minimum number of twists for this type of cable is 2 per foot. Different advantages are there to use this unshielded twisted pair, like it is very cheap, installation is very easy, and it is also used for high speed LAN purpose. But there are certain disadvantages over there, like it can only be used for shorter distances because of the attenuation, and as they are uninsulated, they are affected by the crosstalk or some atmospheric conditions, or some electromagnetic interference, and some uh, adjacent twisted pair is also there. There may be some noise, as well as the noise which is generated nearby. So these are the different disadvantages available for UTP. Another is for so another is the STP. This one, it is a parallel two-way transmission line where it consists of two copper conductors separately by a solid dielectric material. Okay, and the wires and the dielectric are enclosed in a conductive metal slip called a foil. Okay, so the metal here, the metal casing prevents the penetration of the electromagnetic noise, and installation is very easy. Also, it has the higher capacity as compared to unshielded twisted pair cable, and as it has some shielded that provides a higher data transmission rate, and it is less susceptible to uh, noise. But there are certain disadvantages also for STP, like it is more expensive than the UTP, and it has a higher attenuation rate. Okay, so next is the coaxial cable. Okay, the meeting will be ended within one. Okay, so now because of the advent of modern UTP and STP type twisted pair cable, so coaxial cable is seen very less in computer networks, but still has very high importance in analog systems, such as cable tabulation distribution networks. If there is some analog system is there, and the basic where so basic coaxial cable consists of a center conductor surrounded by dielectric material or insulation. Then a concentric uniform distance is to be maintained from the center, and it has some shield. Okay, and finally a jacket. Okay, for environmental protection, outer jacket is there. Okay, so these are two insulator, and after that there is a jacket. Now, two types of coaxial cables are used into transmission. One is called the baseband transmission, and another is the broadband transmission. Like in baseband transmission, um, it is defined as the process of transmitting a single signal at very high speed. But in case of broadband transmission, what happened here, multiple signals can be processed simultaneously. Okay, so there are certain advantages are there. It is capable of operating at higher bit rates, and then the parallel work counterparts very secure it is than the twisted pair cable, and this can be used for long distances. Okay, and it is very immune to the external radiation. Mm, so that's why these are used. And there are certain disadvantages also, like poor cost to performance ratio, like low reliability, and it needs very high maintenance. Okay, now to connect coaxial cable to a particular device, it is necessary to use the coaxial connectors. The most common type of connector is the BNC connector. Okay, now BNC connectors are sometimes referred to as uh, bayonet mount, as they can be easily twisted on or off. Now there are three types of BNC connector: the BNC T connector, BNC, the normal BNC connector, and the BNC terminator. Okay. Now coming to the next type of media, which is the fiber optic media. So the fiber optic cables, that is a cable that uses the electric signals for communication, and a fiber optic cable holds the optical fibers coated in the plastic that are used to send the data by pulses of light. The plastic coating that basically protects the optical fibers from uh, heat, from cold, and some electromagnetic interference from other types of wearing. Okay, and basically it is very faster data transmission media than the copper wires. So basic elements of the fiber optic cable is the core, cladding, and the jacket or the buffer. So I think all of you know about that, the core, cladding, and the jacket. So core, basically it consists of narrow strand of glass or the plastic, uh, which is used as a core, and it is a light transmission area of the fiber. The more the area of the core, the more light will be transmitted into the fiber. Next portion is the cladding. It is called the cladding, the concentric layer of glass, which is known as the cladding. And the main functionality of this cladding is to provide the lower refractive index at the core interface, as to cause the reflection within the core, so that the light waves are transmitted through the fiber. The outer portion is the protective coating consisting of plastic, which is known as jacket or buffer. The main purpose of jacket is to preserve the fiber strength and absorb shock and extra any type of fiber protection. Okay, so there are lots of advantages are available for fiber optic, like very high speed, faster speed is there. It is used for longer distance purpose. It has the better reliability. It is very thin and lightweight, and it has the greater bandwidth. Okay, Next is the unguided media, which is basically called as wireless. So an unguided media transmits the electromagnetic waves without using any physical medium, and that's why it is known as wireless transmission. So in unguided media, air is the media through which the electromagnetic energy can flow easily, and it is divided into three categories like radio waves, microwaves, and infrared. Now we discuss one by one radio waves, microwaves, and infrared in the next slide. Like radio waves here, these are the basically electromagnetic waves that are transmitted in all the directions of free space, and these are omnidirectional. That means the signals are propagated in all the direction. And the range of frequencies which are used in radio waves is that is from the 3 kilohertz to 1 gigahertz. And here the sending and receiving antenna that are not aligned, that is the wave sent by the sending antenna that can be received by any receiving antenna. And this is the omnidirectional antenna, and this technique, this radio waves are used in FM radio. That is the common example.
স্যার দইপানকে একটু অ্যাডমিট করে দেবেন স্যার, ওর আছে ওয়েটিং এ।
Okay, done. So there are certain advantages, like it is basically used for very wide area network and for mobile cellular phones, WAN, wide area networks purpose, and it covers a large area and it can penetrate the walls also, and it provides the higher transmission rates. Next is the microwaves. So electromagnetic waves having frequencies between 1 and 300 gigahertz are called the microwaves. So these microwaves are unidirectional. So when an antenna transmits the microwaves, they can be narrowly focused. That means that the sending and the receiving antennas need to be aligned. And this unidirectional property, it has some advantage. A pair of antennas can be aligned without interfering with another pair of aligned antennas. And this microwave propagation is line of sight, since the towers with the mounted antenna need to be direct sight of each other. Towers that are far apart need to be very tall. And the curvature of the earth as well as other blocking obstacles do not allow two short towers to communicate using microwaves. And that's why we need repeaters for long distance communication purpose. Okay, so it uses the unidirectional antennas that send out the signals in one direction, and two types of antennas are used. One is the parabolic dish antenna, another is the horn antenna. Okay, so basically these microwaves, these are due to their unidirectional properties, these are very useful when unicasting communication is needed between the sender and the receiver. Unicasting communication means one-to-one communication, and they are used in cellular phones, they are used in satellite networks and wireless LANs. Next is the infrared. So this is wireless technology used for communication over short ranges. Okay, and the frequency is to be considered here from 300 gigahertz to 400 terahertz. So it is used for short range purpose, such as data transfer between two cell phones, or TV remote operation purpose, or data transfer between a computer and a cell phone which resides in the same enclosed area. So it supports basically high bandwidth, and hence the data rate will be very high. And infrared waves cannot penetrate the walls. Therefore, the infrared communication in one room cannot be interrupted by the nearby rooms. And this communication provides better security with minimum interference. And it is so these are the different advantages. And one disadvantage is there it is unreliable outside the building, because the sun rays will interfere with this infrared waves. Okay, so these are the different transmission media, both guided media and unguided media I have discussed. So that's all for today. If you have any queries, you can ask me now.